Hello, today I'll be helping you memorize the unit circle with the tricks that helped me best. The unit circle may be daunting when first introduced, though has many neat tricks to help you understand and memorize this useful tool. If you want to see the tricks, you can skip to this part of the video, but if you stick here, you'll get a little bit more background on this fancy circle. So let's get right into it. What is a unit circle? The unit circle is a diagram/tool that consists of a circle with a radius of 1 unit. The circle consists of lines extruding from the center to its circumference. As you see from the most inner set of numbers with the degree symbol, the lines have a spacing of 30, 15, 15, 30 degrees, where this pattern repeats 3 more times to complete the circle. If you take a look at the numbers sandwiched between the degrees and the coordinate-looking set of numbers, those are called radians. Radians are another set of units used to measure angles like degrees and what you may also know as seconds of arcs. If you don't know what seconds of arcs are, it's okay. It's something you probably won't care for a while. So radians. Radians have a special meaning, which makes it a more favored unit of angles and arcs when you get more into math. So imagine you have a string that stretches from the center of a circle to its circumference. So the string has a length of the circle's radius. Now imagine you place one end of the string at any point on the circumference of the circle. Now start placing the body of the string around the circle, making sure the string is being stretched out and the string at every point is touching the circumference of the circle, essentially wrapping the string around the circle as much as you can. Now trace a line directly from the 2 ends of the string to the center of the circle. These 2 lines should form an angle. This angle has a measurement of 1 radian. There are 2 pi radians within a circle, like how there are 360 degrees within a circle. The value of a radian does not change depending on the size of a circle, like how the value of a degree does not change depending on the size of a circle. If you do this experiment multiple times and record the angle of 1 radian, you see that the angle is the exact same size no matter the size of a circle. There is a way to convert from degrees to radians and vice versa. To convert degrees to radians, you'll have to multiply degrees by pi over 180. And to reverse it, you have to multiply radians by 180 over pi. Now the outermost numbers in parentheses. You might have caught me saying a coordinate-looking set of numbers when describing the location of radians. Well, in fact, the outermost numbers are describing coordinates on an xy plane, where the first number is the x and the second the y, or first number is horizontal location and the second is the vertical location. The unit circle can be imagined on an xy coordinate plane, when the center of the circle is at 0, 0, and the tallest point of the circle is at 1, 0, and the most right point of the circle is at 0, 1. As a reminder, the unit circle is a circle with a radius of 1 unit. The coordinates are describing the location of a point on the circumference of the circle at the given angle. The line branching from the center are associating it to. First quadrant carryover trick. There's something that really helped one of my friends memorize the unit circle, and that was they only remembered the first quadrant. You can then just start doing the first quadrant again onto the next quadrant and adding the ending of the last quadrant each time you do it. This only applies to degrees and radians. For coordinates, you can just use a quadrant rule. Quadrant rule says that the first quadrant is positive positive, second quadrant is negative positive, third is negative negative, and fourth is positive negative. I'll get in more detail with this later on. The way I best memorized the degrees was just saying plus 30, plus 15, plus 15, plus 30. If you look at the unit circle, you can kind of see that the gaps between the lines are either big or small. There being only 2 different size gaps, you can just say that the big gaps are plus 30 and the small gaps are plus 15. I also remembered the numbers 15 and 30 by just saying 30 is just 2 15s. This might be but it works for me and maybe for you. You might also have the 30, 60, 90 and 45, 45, 90 triangles memorized. The neat thing is that those two special triangles can be used in the unit circle. Over time, you'll just kind of know all the degrees, but for now, this method should work. The easiest way to remember the radians, in my opinion, is the over 6 and over 4 rule. So take a look at all the parts I highlighted pink. Now let us put a pi over 6 on all these pink highlights. Now starting from 0, you can just count up. 0 pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, and so on. You can simplify them so it looks more to what you're used to, if you like, but your teacher, professor, parent, I don't know who's making you learn this, should be okay with either. Now, I'm gonna remove these highlights and put some green, and make some green highlights. These green sections would be exactly like the pink rule, but instead of pi over 6, we're gonna put pi over 4. And now we can count up. So this is 0 pi over 4, 1 pi over 4, 2 pi over 4, and so on. You can notice that for the over 6 rule, the gaps have an even 30-degree spacing between all of them. And for the over 4 rule, it has an even 45-degree spacing between all of them. This symmetry is what allows for the over 6 and over 4 rule to exist. But if this makes it more difficult to remember, then it's not really that important for now and can be ignored till a later time. For most people, coordinates on the unit circle are the most daunting, but don't worry, there's a nice and clean method to memorizing these ones too. If you take a look at the filled in unit circle, you can kind of see that all the coordinates are over 2, and you may be saying, no, 1 and 0 are over 2, but you can make them over 2 by changing 1 to square root 4 over 2 and 0 to square root 0 over 2. There's a specific reason I chose to change them to square root, and that is, if you look here, if the number is at 1 or square root 4 over 2, you could just start counting down the numbers on the square root until it reaches 0. And if the number is 0 or square root 0 over 2, you can just start counting up. Then you can use the coordinate rules to make the x or y positive or negative. The coordinate rules, or what I call the quadrant rules, say that the first quadrant is positive positive, the second quadrant is negative positive, the third quadrant is negative negative, and the fourth is positive negative. Hopefully these tricks helped you, and if something is still confusing, feel free to leave a comment describing the part that is confusing, and I'll try my best to explain it. Or if you like another topic explained, you can also leave that in the comments, and I'll do my best to make a new video about it. Anyways, I hope your math career goes well, and you can beat your next exam.